this will work. Okay, so it's good to see you all again. About a year ago, I stood here and talked a little bit about software-based production and some of the things that we'd seen in the marketplace, some of the challenges that we had. So I thought I'd just give you a bit of a recap because I gave a little bit of an insight as I wrapped up last year of where I thought this would go and where the market would be. So I think it's, without a shadow of doubt, we've seen more software-defined production tools. I think you see this here at VIDTRANS. I see a lot of IT, IP-based infrastructure. This is not just at Tier 2, Tier 3. We see this at global sports, Tier 1, major sporting events at scale. So, and I think, just to give you an example, here's a couple of the installations that we did over the last year, and it really is low latency, high performance compute. However, there are challenges that come with this, and you've heard several of those challenges during some of the sessions. And so I thought what I'd do is just touch on what we're trying to achieve and some of the challenges we have, and how do we address the question that Felix put out to the wider industry of how do we address this. So I talked last year about the clients wanting to change the way that they work, and that's driven by cost, it's driven by also connectivity, it's driven by issues with working conditions and a number of reasons. But if you look at the kind of tiering from edge to cloud, there are a number of areas where you can put connectivity. So typically at the edge, where signals enter the network, we're not going to go away from that. There's always going to be a need to put legacy signals into the network, traverse them in the network to wherever they need to do something, and get them out of the network where you want them to land. Even simple things like human interfaces, so the audio console, the router panel, again, you might not have any processing there, but you want to be able to interact with that layer. So, but it brings some challenges. So if you want to really build out from the edge to the cloud, you will have done maybe a number of different hops and different transportation mechanisms to deal with things like interoperability, timing, bandwidth constraints, compute constraints, and so you may traverse through multiple different types of networks and in different types of methods of transportation, which is fine. We see a lot of customers doing that, but there must be a better way to address this with the technology that we're using. The other side of it is we also, like a lot of the vendors, have been building out microservice, cloud-native-based infrastructure. And I think as Andy mentioned, there's the control plane and the data plane. Control plane is built of a bunch of services to allow you to discover, to register, to control, to manage the compute layer, but also the data plane. And then at the lower layer, the infrastructure layer, using standard off-the-shelf compute, is being able to have a common compute stack that you can run your processing technology on. Whether it's singular discrete processing nodes or clustered processing nodes. And so this architecture we see more and more. We see some customers putting up the microservice orchestration layer up into the public cloud and then putting the data plane down on premise or doing a combination of both. But when we talk about processing or we talk about apps, most of that work has already been done to detach the parts or break out the parts of that app. So inputs and outputs, the stream in, stream out will vary, whether it's 2110, NDI, SRT, WebRTC. But once you've brought the data to the app and you want to process it, you really want to get it into shared memory, process it, keep the latency down, get it back out, and put it back out on the wire. And so certainly from the architecture we've been building out is to really from day one from the apps to break them into this granular step, to prepare them for the future to, if we need to, extend the shared memory between apps. So what does that look like? For those of you familiar with containerization, you have a bunch of services. An app will have lots of services doing lots of different functions, inputs, outputs, graphics rendering, processing blocks. And so when you instantiate an app, it'll spin up a bunch of services, pull them down from the registry. When you're done with it, it'll just tear them down and free up the compute. And so whether you're using Docker or using pods with Kubernetes, it's a kind of similar approach. And so you can build out fairly complex, high-performance infrastructure and also put a certain level of security into that by isolating out the separate services. So what is the challenge? That's the challenge, because if Lawo just builds apps on single servers, yes, you get the benefit of IP and IT, but you only get it from a single vendor. And you can't have vendors with their own versions of servers. That will not scale. And the way we get around that today, honestly, is people lift and shift virtual machines, which is kind of a step backwards, not a step forward. So this is the challenge that we have. And so if you want to build out modern dynamic media infrastructures, you have to find a way to let the vendors all collaborate on the same IT infrastructure, whether it's on-premise or whether it's in the cloud. So what is the challenge? It's to avoid this, honestly, which is the standoff between all the vendors of who's the best, because this won't wash. And so as an industry, we've done this many, many times, and I think Felix mentioned this, it just stalls customer investment, it stalls them moving forward. And so I think we have to be realistic that memory sharing, or what we talk about, is just another form of passing signals between each other. So we did that in the past, it was on copper, we've done that in IP. We just have to move forward and say, actually, that we've got to find a much better way to do this. So you saw this earlier, it's the EBU stack. So talking at the application industry specific blocks, and then the lower generic blocks of the compute. So if I kind of break them on the right-hand side into a little bit more of sub-blocks, in the media exchange, you have shared memory. In shared memory, we put audio, video, auxiliary data. In the container platform, that's where we're running up the services, so there is a need for interfacing and orchestration. And in the lower tier, you have the compute, whether that's on-prem or in cloud. And again, that will have CPU and GPU depending on the infrastructure that you have. So when you look at these layers, if you look at the control plane, that ultimately is important to instantiate applications. It's there for a number of things, communicating with applications. It's also for looking at monitoring health status of applications, making sure that they're provisioned correctly. So if you need X number of cores are preserved and they're also assigned. The compute layer is basically where we put the data to process the audio, the video. And the shared memory is how do we put the data into the shared memory? So how is it structured and how do we get to it? So just to go through a couple of simple use cases, if you take two apps today on a standard host, you'll come in with one format, maybe 2110, you'll process the frames or grains in memory, and then you'll put it back out on the wire in maybe the same transportation mechanism or in a different one. So 2110, NDI, or SRT. And if you want to go between apps, even on the same box, you may come in one flavor, process in shared memory, go back out, back in again. Well, that has a cost. It has a latency cost, and it has a compute cost. So every time you receive a stream and you unpack it, that has a cost. Every time you have to repack it and put it back in again, it has a cost. It also has, to a certain degree, a lot of complexity in customer workflows and in the upper layers. So obviously in there, you could decide to say, okay, I remove the output and the input services, and I just share the memory. If the content is already in memory, why do I repackage it to put it back in the wire to unpack it again to receive it? So that's a way of doing shared memory on a single host. You might decide that I receive something, but I want to do a little bit of processing before I put it into memory. So for example, if you have something like a multi-viewer, you bring in UHD. Instead of just put the UHD in shared memory, I can also put in the different raster sizes at the same time, which means that the target device can choose to pull out of memory whichever raster size it needs. Reduces bandwidth. It also reduces a lot of the complexity by having lots of different cascaded processing. And again, that could be between two apps on the same host. And again, if you think about the cascading of apps, the real key here is today, if you're doing multi-vendor app cascading, you will have a cost for the inputs and outputs in the same way as if you went through hardware modular. So if you're going in and out for the same reason. And so if you want to really have multiple vendors, the most efficient way is to access that shared memory. And then obviously you can go between different hosts. So server 1 to server 2 or server 5 to server 10, just be able to exchange the memory between different hosts. And again, processing in some of the apps and some in different places. So what does that mean? There's quite a bit of work around the media exchange layer, so we've been quite supportive of this. We believe it's really critical for the industry. We don't need to reinvent the wheel here. I think when we look at putting video into memory, it makes sense to also look at what's going to serve us well in the future. So, you know, it might be that we have traditional baseband infrastructure come into IP, but we will also have a lot of devices and processing that have different needs. And so we are a strong supporter of putting 16-bit planar 422 into memory. It's fairly easy to do. You've seen some of this today and yesterday in some of the exhibition stuff. So we believe this also gives us a path to 444 and to also alpha support in the future. So the other thing that's really important with a video is you need to put some level of metadata, and I really strongly advocate that we move away from things like SDPs to pass metadata. The data should sit with the frame, and so I know what's in there, and from a raster size, from a frame rate perspective, the source timestamp is in there. So it's really quick for me to get to the data that I need to be able to make decisions and reconstruct video. And again, you know, for example, just simple metadata of where lines are and so on. The metadata, I think we could put quite a lot in there, but I think we should have the base minimum we need to be able to determine what's currently sitting into memory. The audio one's a little bit more contentious, interleave versus discrete. We're also, as you can imagine, as an audio company, big advocates for putting audio in a way where it's low latency and usable. And so, generally speaking, and this is the thing you saw from the Riedel presentation, that's more than achievable with this approach. And so, in here, you can bring it down 2 channels and then take a sort of a power of 2 upwards, and this works really well. We believe it's really low latency, so if we look at the work we've done with our MC² DSP processing app and software, we achieve very low latency, and we're able to have a variation of channel packing inside of that. So one thing I would say here, again, storing the metadata is important because then you can make that memory effectively sample rate and bit depth independent. So if you're thinking about 48 or 96 kilohertz or other things in the future, it allows you to accommodate potentially future things as well. But one thing that's really important with the memory stores, we also have to be careful to stop the data from going stale. So leaving remnants and stuff in the memory store, that's also quite an important factor, which we have a responsibility if you're writing into the memory. So auxiliary is actually an easy one. It's probably the least contentious between all the vendors, is we have a mechanism. There's RFCs and there's SIMD work around here, so just take the ANC packet, put it in the relative space, store it, and use it accordingly. So we believe this allows us to go and pack video, audio, and auxiliary with very low effort into memory. And as you heard from the Riedel team, libfabric is a great way to exchange that even with inside a node and across nodes using libfabric. So we believe that this is absolutely a way forward, a tangible way forward. There's quite a bit of work done with a lot of the vendors to move this. But what about the other layers? Because, like I said, there are other challenges that we have to look at and we have to take care of. This is entirely based on multi-vendor applications. So we talk about live, but there's a convergence here of non-live. So there's a high probability that the application layers at the top are receiving live grains of video, but they're also putting it down into storage and reading it up from storage. And so we shouldn't lose sight of that the ecosystem will probably go a lot wider than you're used to. Orchestration is really important. Somebody's going to have to take care of this. So if you're going to use containers or you're going to use Kubernetes, you need to have some sort of central repository for the services. They need to be secure. They need to be version control managed. When you go to spin up the applications, things like core pinning, dealing with siblings, dealing with L3 cache allocations, that's going to have to be done in the correct way to ensure that you don't over-provision or under-provision the application on a box. And then also things like network, when you instantiate connections between nodes, whether they're 2110 or whether they're memory sharing, you've also got to take care to instantiate it and tear it down when it's finished. So roles and permissions become really important. because you don't want lots of people writing to the same space, and you also might not want everybody reading from the same space, and you might not want everybody having access to all of the capability of the system. So this will inherently become a key part of this, I believe. And I touched on it, but the cleaning up is going to be important. If you're an application and you're writing into memory, you're going to be responsible for cleaning up after yourself when you tear down the app. That's going to be something that is, there will be no God service that comes around afterwards and just clears up all the mess. There will need to be a little bit of a good citizen in that infrastructure to make sure that as you use it, you also take care for it. And the API, I think, is an interesting one. So MOS was talked about. There's other, I think yesterday we got dragged into lots of protocol discussions of which one's the right one. I'm of the opinion that just have a very good, well-documented API that's open and people can work to. Make it kind of protocol agnostic so people can choose what's best. Because if you're going to put this in public cloud, you're probably going to have some other challenges there as well. And security, make it the first class by design, not an afterthought. So one of the benefits of going to containerization is the isolation we can get of the containers away from the OS. And so then things like intra-service messaging between apps and the external APIs should come with a security-first approach. The underlying layers, I think that this was mentioned in one of the presentations. It's built on containerization. Whether you choose to put it in Docker or Kubernetes, I think varies by product or access to market. What we tend to find personally is if you have customers who are not so familiar with containerization, Docker is a good step. Kubernetes might be a bit of a challenge for them if they don't have people with that experience. But I think in here, if you start with a containerization approach first, you can always get to one or the other. And from a compute perspective, we want to leverage all the benefits of high HPC compute. And in this case, we should not be just welded to x86. ARM is important. It's important if you're putting things in public clouds, AWS with Graviton, NVIDIA with Grace Hopper. So any of the containers that we compile or we build or should really be able to run on any type of node. And of course, from the Lawo side, we always try to make all the apps CPU as the baseline and then can use GPU if it's available for acceleration. So, and again here, whether you're using discrete or using devices that have CPU and GPU welded together, I think that's also something that has to be considered because it has an impact on how memory is shared. So whether you're sharing on host memory or whether you're sharing it through the GPU memory. One thing that I think we need to do a little bit of work around is the network. So today we build fairly, I would say, straightforward networks, but in this type of topology with clustering, you're going to have north and south network interfaces for maybe transportation formats coming in and out of the cluster, and you will probably have east and west traffic for all of the intra-node transfers. And so this will mean that the design of these systems are probably slightly different to the way we've built media and entertainment network systems, and that's something that should be thought about. It might also mean that every system we build doesn't necessarily have to start with, do I need an SDN? Because maybe some of the connections around the box can be managed, but maybe within it, it's self-managing. And from the lower layers, from the hardware layer, I think what we've been pretty clear in the working group for the DMF is that it should be really, if it's vendor agnostic at the application layer, it should also be vendor agnostic at the lower layer. So whether you're using Holoscan or the Intel Tyra suite, or you're using discrete nodes from Dell or Supermicro, it shouldn't really matter. It should be, the technology stack should be able to extend across. And again, private and public cloud is linear expansion. Allow it to expect to go where it needs to go in order to serve the customer's business use cases. And I would just echo what the Real team said. I think we shouldn't reinvent the wheel here. We should take technology stacks that are used for exactly this type of use cases, which is a lot of data moving as quickly as low latency as possible. So things like libfabric are really a good step forward. So what would I say, based on what I presented last year, and the first slide of what we're trying to achieve from the edge to the cloud? We want to remove the complexity. All these hopping in and out of different transportation formats and connections, We will probably still have to do that, but we should be able to get to a point, hopefully, where we can have an edge-to-cloud media exchange layer. That would be highly desirable. It would solve a lot of problems around latency. It would solve a lot of problems around orchestration and management of the infrastructure as well. So for me, this is really important. Of course, this is only the interchange format. But if we can't do that, then none of the other parts actually matter. So, but we will have to tackle some of the other points as well. So conclusions, I'm a strong believer that we shouldn't build it from the past. We should build for the future. Of course, we have legacy infrastructure that is obviously there. But again, if we look at the convergence aspect of this, converging with live and non-live, and with things like cameras and graphics engines that do way more than 10-bit color space, there is going to be a need to make sure we don't build something that is already dated by the time we get it to market as an industry. But what I would say is V210 10-bit video is a good starting point. That has been where the group has started in the DMF. But it shouldn't be the one and only thing that we do, because we have to go way beyond that. We don't want to have to redo this again, I guess is what I'm saying. The AV media functions, we should not ground the technology that we choose to the lowest common denominator. Yeah, there are different media functions and they have different requirements. We cannot just bring them to the lowest part. So there is audio only, there is audio and video applications, there's video only applications. Not one size fits all, and they all have different types of needs, whether it's latency or processing. So I think this is really important. Convergence is inevitable. So we talk a lot about technology, we don't talk about the business, why customers want to do this and what's the benefits for them. So they want to converge all their workloads onto one common platform, whether it's on-premise or whether it's in cloud or whether it's burst to the cloud. They want to be able to do the convergence because that's where they get the maximum efficiency of their infrastructure. And my next point here is about standardization. We should not repeat 2110 standardization. That took too long. That's my personal opinion. The industry won't wait for us to take that time. It will move on and we'll have real big challenges. And so my view of it is it needs a different approach. And so you see the work that the EBU has been doing with the CBC. This really shows a commitment from the industry and a recognition from the industry that they need to move this quicker in a way where it doesn't stifle innovation inside of our industry. And so what I would say, things like Apache 2 are a great way to get past that in terms of the media exchange. There are other things that have been looked at, but as you heard Felix say, this is an area where I think it's going to make potential sense. But there is a call of action here. So I said this last year, the industry has to get on, we as an industry have to get on board and we have to move it together. If it goes fragmented, the customers will just sit and wait to see which one is the path forward. So this will only move as quick as every person participates in the process. So yes, the EBU one, the initial meeting is with a set of vendors and customers, but as you saw from Felix, there's another one coming in March. People should attend and participate because this is important and it's important that it's done right. So, and my last point here is we don't have time. So I already showed you projects that we've done as a company at large scale global events, massive US-based trucks that are running with it, large broadcast infrastructure here in the US. Customers are building infrastructure and projects today with this technology stack. The only thing that they're missing is the support between multi-vendors in the same side of that stack. So their projects are coming. They're there, they're tangible, and so we don't have any time to lose. What will happen if we don't get to this is we'll get dragged kicking and screaming to it, and because that's the desired outcome from a lot of our customers. So I think, just to cap this up, I think this is, you see the importance of this at VidTrans. There's a lot of talks on this. There are a lot of capabilities in what is available today, but it needs actively steering because there's also a lot of questions that don't have answers. So.